All right, so last class we had reviewed cosine law and sine law. And if you remember, we were talking about how you can use sine law when you have an angle and a side length pair given. Now, there is something called an ambiguous case. So there's one specific triangle, and it's called a SSA triangle. So a side-side angle triangle. In fact, it looks like this. You're going to be given a side length, and angle, and one of the angles and side lengths will be paired up together. And when you have a situation like this, you can have something called an ambiguous case. And all that means is your specific SSA triangle can be drawn in two different ways, and then it has to be solved in those two different ways. So we're going to talk about how you can identify if something is an ambiguous case. And the reason why I was saying that this lesson can be a little difficult is because there are a lot of rules and checklists to go through to determine if something is going to be ambiguous case. Okay, so I'm hoping today we can go through all the rules and we'll get started on the questions. However, we're probably not going to finish. So this lesson will continue in tomorrow's class. And then hopefully in tomorrow's class, it'll feel a lot more clearer than it is today. So the little blurb says, an interesting problem arises when two sides and an angle opposite one of them is known, so SSA. We will always be drawing our diagrams as shown, and we'll be using the sine law a lot. So whenever we have a situation like this, we are always going to be putting our angle on the bottom left-hand side, and we're going to call that angle, A or whatever it is. And then we're going to be putting the side length across from it, and these two will always be given. The other side length that will be given to us, we will always draw in this position. So we're kind of going to mimic this diagram, and we will make sure we're very consistent and are always drawing this. Okay, so step number one is determine if a triangle exists at all. So there can be situations where no triangle exists, and we have to figure out which situations that is. So the first thing you're going to do is you're going to determine the height of the triangle. The height of the triangle is measured from the vertex down, and you're going to label it H. And you're going to recognize that when you draw that H, it actually creates two right angle triangles. So you have a right angle triangle here and a right angle triangle there. So now the theta is here, side length A is here, side length B is here. You are going to be using the theta to determine H. And to do that, we're just going to use SOHCAHTOA, because remember, you can use SOHCAHTOA for a right angle triangle. So sine of theta is going to be equal to H over B, opposite over hypotenuse. And I've written that right over here. And then you're going to rearrange for H. So H is going to be equal to B times sine theta. And that's how you're going to figure out the height. And that's always step number one. When in doubt, figure out what the H is using that little formula. H is equal to B times sine theta. Once you have done that and you now have a value for H, step number two is you are going to be comparing your H and your A values. Okay, now there are actually two different sets of rules depending on what kind of angle you have. And I'm going to start with the rules for an obtuse angle. What does the word obtuse mean? Right, so if this angle given to us right over here is greater than 90 degrees, it's an obtuse triangle, you're still going to calculate, oh, actually, if it's an obtuse triangle, you don't even need to calculate H. If you did, it's okay. But what you're going to do is if angle A is obtuse, greater than 90, you don't need to calculate H. You're just going to compare side lengths A and B. So this side length and this side length. So actually, when I'm doing examples, I always identify my obtuse angles first because I feel like those are the easiest ones. You don't actually have to calculate much. You just have to compare the two side lengths. And honestly, I don't memorize any of these rules. I just use logic. So if the angle is obtuse, it's going to look like this. And you're going to compare the side lengths A and B. And if you notice that side length A is shorter than side length B, then no triangle exists because that line is not going to be long enough. It's going to fall short. And so in that case, no triangle exists. You wouldn't even draw the entire triangle. You would just leave it like that. If side length A and side length B are exactly equal, again, no triangle exists, because if you take a look at this, your side length A has to be significantly longer than your side length B in order for the triangle to exist. So if A is shorter than B, no triangle will exist. If A is the same length as B, no triangle will exist. The only time a triangle exists when you have an obtuse angle is when side length A is larger than side length B. This is not ambiguous case. This is just telling you if a triangle exists or not. So for an obtuse angle, you just compare A and B and you determine if there's no triangle, if one triangle exists. And if one triangle does exist, then you can use like sine law, cosine law, whatever you need to solve that triangle like we did yesterday. Okay, so that's like the easier stuff. Now, this lesson, which is ambiguous case, occurs when you have an acute triangle. So if the angle is less than 90 degrees. Okay. By the way, there's a little rule. I don't know if you guys know this, but did you know the largest angle is always paired up with the largest side? We kind of talked about this yesterday. So just fun fact, which will kind of help us here. If you have a really large angle, it'll always be paired up with the largest side. If you have a very small angle, it's going to be paired up with the smallest side. Okay, so once we've calculated our h, what we're going to do now is we're going to compare our h and our a. So the height and whatever side length is on the right-hand side. Now, if you take a look at this, this is a right angle triangle technically. And if this is a right angle triangle, this is the hypotenuse. And we know the hypotenuse has to be the longest side length. So remember that when you're comparing your A side length and your H side length. Okay, so if you have a situation where your A side length is shorter than your H side length, is that possible? Is it possible for our hypotenuse to be shorter than the other side length? No. So in a situation where the A side length is shorter than the H side length, no triangle exists. You can't calculate anything. You just write down no triangle exists. In the middle situation, when your A side length and your H side length are exactly the same, what ends up happening is you actually end up with a right angle triangle. And that's basically because imagine your A side length and your H side length sort of combining, and you get one triangle which looks like this. So if the A side length and the H side length are exactly the same, the only triangle you're going to have is a right angle triangle. You can use SOHCAHTOA to answer your questions. Okay, this last scenario is the one you have to be most careful of, and that is when side length A is larger than your height of your triangle. So if A is greater than H, then that is a situation where it might be an ambiguous case. Okay, let me pause here. Okay, so like I said, when side length A is greater than H, we have to do our final checklist to figure out what is happening. So go to the next page. We're going to be checking for ambiguous case. And you can only find an ambiguous case when the angle is acute, so less than 90 degrees, and also when side length A is greater than H. So only when all of those situations line up, that's when you do your final check for ambiguous case. Okay, the final check for ambiguous case, you are going to be comparing side length A and side length B now. So the H doesn't really matter. If you find that your triangle is leaning towards the left, so I call this a leans left triangle. Do you notice how it's kind of like shifted to the left? If it's leaning towards the left, that means side length A is longer than side length B, and only one triangle exists. Okay, so when side length A is larger than side length B, it's leaning towards the left, only one triangle exists. If you compare A and B and you notice they are exactly the same, that means it's an isosceles triangle. And again, only one triangle is going to exist. When your triangle leans to the right, and when that triangle has side length A that is shorter than side length B, that is the perfect scenario for ambiguous case, and that means two triangles are going to exist. How do I remember that? Well, in order for something to be ambiguous, which you're going to learn right now, you need this little arm to be able to swing to the other side. So if it's short enough, if the angle side length A is really short, you can take that side length A and you can actually swing it and kind of draw it like this. So that is the situation where you can now draw two different triangles. I'll make a note of that, and then that's something we can look for. So this side can swing this around. and it's also leaning to the right. In this case, it's leaning to the left, but we can't swing this around because side length A is too large, right? It's too big that if you try to swing it to the other side, it wouldn't fit. So that's another way that you can tell something is an ambiguous case. Yes. Yes, so when A is shorter than the B side, that is when it's going to be ambiguous. That one is ambiguous, yes. Marju? Yes, like you can't swing it around, so that's the only possibility. You would just solve it as is. Oh, no, not, yeah. Bea? Sure, yeah. If I were to list the steps, what I would first do is after I've calculated H, I would compare my A value and my H value. And when I did that, I would have to, first of all, I would check to see if it's an acute triangle. So number one, theta is acute. Then step number two, compare A and H, and you want to make sure your A value is larger than your H value. Then you use the rules for obtuse, in which case it won't be ambiguous, but it can be one triangle or no triangle at all. So it has to be acute, theta has to be acute. Step number two, you compare A and H, and A has to be bigger than H. And then step number three, you compare A and B. So I'll just write over here, A is greater than H. And then you compare A and B, and A has to be smaller than B. And by the way, the triangle has to be a side length, angle triangle. So when all of these situations line up, it's acute, A is greater than H, and A is less than B, then it is considered to be ambiguous case. Okay, so let's say all of the three rules are now true, and you end up with an ambiguous case. How exactly are you going to draw your two triangles? So like I said, side length A over here can swing to the other side, and that's what's going to give you your new side length. And whenever we're talking about a new side length or a new angle, we're going to have a little, it's called a prime. So we're going to call it A prime, just to show that it's part of the new triangle. So you're going to imagine that side length A is swinging over, and you have a new side length A prime over here. Because A and A prime are both the same side lengths, you actually end up with an isosceles triangle on the inside over here. So this angle and this angle end up being the same, and this is now an isosceles triangle. And that's going to help us solve this triangle when we do it. Sarah? I just mean yeah, no, just this part right here. Yeah. So when we identify something's ambiguous case, you have to draw it in two different ways. The first way is the original triangle, right? Oh, and by the way, just thinking back to our supplementary angle rules, if you know the angle here, you can figure out this angle here by just going 180 degrees minus whatever the dot is. So that's going to help us a little bit figure out all the different angles. And I'm just going to show you that I have swung this arm over here to give you that new arm. Sarah? Once you figured out something's ambiguous, you have to draw the two triangles. So the first triangle is actually the original triangle that was given to us in the question. So let's go ahead and call this maybe case number 1 or triangle number 1. So this is just going to be triangle ABC. Everything is from the original question. There's no prime or anything like that. However, this is case number 2. And we're going to call this triangle ABC prime. So look, if this is angle A, it remains angle A. Nothing changes, right? We're not touching that. Technically, if this is angle C, there's a little mistake on this. We should call this C prime because it's actually not going to be the same as angle C. It's going to have a different measurement. So just change that C up there to C prime. This is A prime. It's going to be the same measurement of side length A, but because it's in a different position, we're going to call it A prime. And then this is going to be B prime because it's going to have a different measurement as well. And this is going to be C prime. So the only things that stay the same are angle A and side length B, and then everything else is going to be brand new. How do we feel about this? So you guys, the reason why I made that other handout is because I found this chart to be kind of confusing, but if that handout didn't help, all the rules are listed there. Again, you could take a look at them and see if it makes a little bit more sense. All right, so here are the types of questions you're gonna see when you've been given an ambiguous case question. So it says, determine the number of possible triangles that could be drawn with the given measurements, then solve the triangles. And our possibilities are no triangle exists, one triangle exists, or two triangles exist, and that's ambiguous case. So the first thing I'm going to do is I'm just going to roughly draw this and try to figure out what's happening. Do you guys, first of all, triangle ABC, that's great. Whenever I'm given an angle, I always want to draw it on the bottom left-hand side of my diagram. Okay, you always want to put your angle there. So this, don't copy this right now. I'm just going to show you. Maybe it looks like this. Let's just take a look. So I'm going to label this angle A. We'll draw it properly later. This is 42 degrees. Across from angle A has to be side length A, and that is always going to be given to us. The pair will always be given, and that's going to be A is equal to 30 centimeters. And then the other side length I always put over here. And then I check. I say, okay, if I want to be accurate, side length A is larger and side length B is smaller. So if I'm doing this properly, you want your triangle to look like this, right? Because you want the smaller side length to be smaller and the larger one to be larger. So I always get a rough piece of paper, I sketch it out, I put my numbers in, and then I say, okay, I need a little bit more of a realistic diagram. This one needs to be such that B is shorter and A is longer. Okay, so now we're ready to go ahead and draw it properly. So what I'm going to do is I'm going to start off with the base. And then I'm going to have this side length here. And then I'm going to have this side length. Oh, this program is working today. And then whatever angle is given, remember, write it on the bottom right-hand side. Sorry, bottom left-hand side. That's going to be 42 degrees. The corresponding side length, it's going to be A is equal to 30 centimeters. We don't need to write the centimeters. This has to be angle B because we want the other given side length to be on the left-hand side, which is going to be 25 centimeters. And then it says triangle ABC, so that means this is side length angle C, and side length C is at the bottom. Because these questions are so specific, you actually need to make sure your triangles are drawn accurately, okay? So if there's a certain side length that's larger or smaller, make sure your diagram actually reflects that. Marju? All right, we've drawn the triangle. Is this an acute case or an obtuse case? Well, first of all, is this an SSA triangle? Yes, it is, because we have a side length, and an angle. So we can be sure that we need to check for ambiguous case. Next, I look at the angle. It's less than 90 degrees, which means it is an acute triangle. So we're going to be looking at all of the rules for acute triangle. What is step number 1 in calculating for ambiguous case? Good. So you're going to go ahead and draw in your H, which is just going to be a dashed line from the vertex down. I just put in a little 90-degree sign to remind us that you're basically creating 2 right angle triangles, and then you're going to label it H. To find H, it's just SOHCAHTOA. So you can memorize that it's H times sine 42, sorry, B times sine 42, or you can actually do the work. So you can go sine of 42 is equal to opposite, which is H, divided by hypotenuse, which is 25. And then H is going to be equal to, we need our calculators, make sure they're in degree mode. So sine 42 times 25. And because we're not, this isn't our final answer, I'm not going to round it because I just want to try to be accurate. So maybe I'll just keep 3 decimal places. All right, now that I've calculated H, if you go to your rules, what 2 side lengths are we going to be comparing? Sarah? Good. We're going to compare H and A. Just so I can see this, I might just write it down here. It's 16.7-ish. Okay, so according to the rules, in this case, my A is longer than my H. So A is greater than H. So therefore, oh, I don't have the rules in front of me. Take a look at your little chart. If A was less than H, no triangle would exist. If A and H were exactly the same, it would be a right angle triangle. If A is greater than H, we need to now check, it might be 2 triangles. So therefore, we're going to check for ambiguous case. Yes. These are sort of like your proofs. So you need to make sure that you're checking A and H first and then determining what's happening. So A is greater than H, therefore we're going to check for ambiguous case. Okay, now we're on to the next side of our check. What 2 side lengths are we comparing? Good, we're going to compare A and we're going to compare B. Now, the rules are if A is greater than B, if A is greater than B, can you take A and swing it around to the other side? Can you have 2 different scenarios? No. So therefore, how many triangles exist here? And is it an ambiguous case? Only 1 triangle exists. It's not an ambiguous case. So we're going to write that down. And by the way, which way is this triangle leaning? Yes. So you know if it's leaning to the left, it's not going to be an ambiguous case. So we're going to go ahead and write down A is greater than B. Therefore, 1 triangle exists. So it is not an ambiguous case. Okay, now the question says solve the triangle. So that means we're going to go ahead and use sine law and just solve for the rest of this triangle. Sarah? Triangle. We're basically looking for angle C, side length C, and angle B. Because I know this is sine law, I'm going to start by finding angle B, and I'm going to use sine law to do it. So it's going to be sine B over side length B is equal to sine A over side length A. This is our lesson from yesterday. Whoa, I did it. Sorry, yeah, that's right. So I'm trying to find sine B, and that's going to be equal to 25 times sine 42 over, I'm kind of substituting and rearranging at the same time. So it's going to be sine 42 times 25 divided by 30. And then I'm just going to go ahead and do sine inverse. I won't show that middle step. And I get 33 point, it's a final answer. So it's going to be 33.9 degrees. Okay, so we figured out this, it's 33.9. How can we figure out angle C, Sarah? No, and you don't have to show that middle step either, where it's like sine B is equal to whatever decimal. Now that we've learned the lesson yesterday, you can go straight to the answer. Yeah, perfect. Yep, it's going to be the interior angle rule. So in order for us to find angle C, we're just going to go angle C is equal to 180 minus 42 minus 33.9. If you're wondering, well, should we have rounded? Should we not have rounded? Because eventually all of these are going to be our final answers. I'm okay to round it. Or you can keep it unrounded and then at the end list all your answers rounded. It's up to you. So 180 minus 42 minus 33.9, and I'm going to get 104.1 degrees. And then for the final part, we're going to look for side length C. So we cannot use the Pythagorean theorem. We're going to have to go ahead and do sine law again and figure it out that way. So to finish off this question, yeah. I mean, if it's a 90-degree angle, then you can, but if it's not a 90-degree angle, you cannot use Pythagorean theorem. Yeah, Marzu? So this is going to be C over sine 104.1. Sorry, this isn't showing up. Okay. C over sine 104.1 is equal to, and now you can actually use A or B. I always pick the side lengths that were given to us just because they're probably the most accurate. So I'm going to go A over sine A. You know what? I'm thinking I should probably write the formula first. So let me just do that on the side over here. So it's going to be side length C over sine C is equal to side length A over sine A. And now we're going to plug in our information. So sine C is 104.1 and side length A is 30 over sine A is 42. So I'm just going to move on here. C is going to be equal to 30 times sine 104.1 all over sine 42. 30 times sine 104.1 divided by sine 42. I get 43.5 centimeters. Did you guys get that as well? Now that actually was an ambiguous case, so it was just a regular triangle, but how was the steps, like finding all the stuff? Was it okay? Not too bad. We're gonna do just one more example, question B, and then I will stop there, and then you guys can just learn the rules and relax. Marzu, question? No, you don't. I just want to be accurate when I'm doing the solution, but I would be fine if you just plugged in the information directly and then did that way. Okay, I'm just gonna move this here. All right, question letter B. So again, take a look at the diagram, the question. In this case, we're not using A, B, and C, but that's good because we want to just practice using letters that are not the same. I'm going to start off by drawing a rough triangle. So I don't know exactly what the side lengths are. I'll just draw it like this. I know if W is given, then I'm going to write it over here. That's going to be 38.7 degrees. And then little w will be 10 centimeters. And the other side length, just for consistency, I'm going to keep it over here. That means it'll be big V, and then the other letter will be U and little u. I take a look at the side lengths, and I know that W is smaller than V. So when I'm drawing it, I actually need to make side length W a lot smaller. So now I'm ready to actually draw it, and I'm going to make this look like this. It was not my intention to make it tilted like this. I don't know if it's going to throw anyone off, but I can do it one more time. Oh no, it didn't connect, so it didn't make it into a triangle. Let me try it one more time. There we go. Okay, so this is W, which is going to be 38.7 degrees. This is little w, which is going to be 10 centimeters. This is angle V. This is little v, which is going to be 25 centimeters. And then we have u over here, angle u, and then little u over here. Okay, so let's do our check. This is a side-side angle triangle, and it is a cube. Marzu? I always do it such that if you take a look at this, and again, like I said, it's just for consistency. I always want my angle to be drawn here and the corresponding side length here, and the other known side length, I always want it on the left-hand side, because then all the rules we've memorized just fall into place. The U's? I mean, they would just go in the other spot, but no other information is given about them. So yeah. Okay, so we're going to begin by first calculating h. So let's go ahead and do that. Make a dashed line from the vertex down and label this h. This is going to be sine 38.7 is equal to h over 25. And so h is just going to be sine 38.7 times 25, which is going to be 15.631 centimeters. Sorry, not 361. 631 centimeters. Okay, once we have calculated h, we are now going to compare h, and technically it's a, right? We always compare a, but in this case, the letter in the a position is just w. So really all we're going to do is we're going to compare this and this. So take a look at them. Our h is 15.631, our w is 10. Go back to your rules. Is the hypotenuse of a right angle triangle, which this is the hypotenuse allowed to be less than the actual other side length? So remember, 10 is supposed to be the hypotenuse, and this side length is 15. So the hypotenuse is less than h. Is that possible? Are we allowed to have that? No. So because side length w is less than h, therefore no triangle exists, and that's it. You can't do anything else. You can't calculate it, and that's the end of the question. And the majority of your questions will just be no triangle exists, because there's so many scenarios. It's just very rarely you'll end up with like one triangle or no triangle. By the way, you guys, to show that no triangle exists, you do have to go back to your diagram because it's not accurate, and you do need to erase the a part of the line to show that side length W is actually not as long as side length H. It falls short, and that's why no triangle exists. All right, that was a nice long introduction to ambiguous case. We're gonna pause here. In tomorrow's class, I'm gonna go over the rules really quickly, but I'm hoping you will memorize them. And then we will do questions C, D, E, F, and G. So 5 examples, and then I'll give you some textbook questions for you to try on your own.